Free fall. Let us first perform one activity. Let us hold a small stone in the hand and identify the forces acting on the stone. Two forces are acting on this stone. The Earth's gravitational force acting on the stone and the force applied by us to hold the stone are the two equal forces which are acting in the opposite direction. Come, let us now release the stone. What do we observe? As soon as we release the stone, it falls down due to the Earth's gravitational force. We know that the force of gravity due to the Earth acts on each and every object. When the stone was held in the hand, even at that time the stone was experiencing this force, but it was balanced by a force applied by us on it in the opposite direction. Consequently, the stone remained at rest. Once we release the stone is acted upon by the force of gravity alone, due to which it falls down. Whenever an object moves under the influence of the force of gravity alone, it is said to be falling freely. Here, the released stone is in a free fall. In free fall, the initial velocity is zero and it goes on increasing due to acceleration due to gravity. During a free fall, frictional force due to air resists the motion of the object and a buoyant force also acts on it. Thus, in true sense, a free fall is not possible in the presence of air. It is possible only in vacuum. For a freely falling object, the velocity on reaching the Earth and the time taken for it by a freely falling object can be calculated using Newton's equations of motion. For free fall, the acceleration is g and the initial velocity u is 0. Thus, the modified equations of motion for freely falling bodies are 1. V is equal to gt. 2. S is equal to 1 upon 2 gt square. 3. V square is equal to 2 gs. Here, v is equal to final velocity, g is equal to acceleration, t is equal to time, and s is equal to distance covered in time t. While studying the motion of an object thrown vertically upwards, g is taken to be minus g. It is because, in this case, acceleration is in a direction opposite to the velocity. The magnitude of g is the same, but the velocity of the object decreases because of this acceleration. The moon and artificial satellites are moving only under the influence of the gravitational field of the Earth. Thus, they are in free fall. Do you know? As per Newton's universal law of gravitation, Earth's gravitational force is higher on an object of larger mass. But the object with larger mass does not fall down with higher velocity as compared to an object with lower mass. It is because the value of g is the same for all objects at a given place on the Earth. Therefore, any two objects when dropped from the same height fall freely and will reach at the same time. The time taken by the freely falling object to reach the Earth does not depend upon the mass or any other property of the object. It is said that Galileo had performed an experiment around 1590 in the Italian city of Pisa. Galileo dropped two spheres of different masses from the Leaning Tower of Pisa to demonstrate that both spheres reached the ground at the same time. When we drop a feather and a heavy stone from a height at the same time, then they do not reach the Earth at the same time. The heavy stone reaches the Earth before the feather. This happens because the feather experiences a frictional force due to air and a buoyant force due to which it floats and reaches the ground slowly later than the heavy stone. The frictional force and buoyant force are the forces on the stone which are much less than the weight of the stone, and thus these forces do not affect the speed of the stone much. Recently, scientists performed the experiment of a stone and a feather in vacuum and showed that the feather and stone indeed reached the earth at the same time.